Hello, my name is John Gonzalez, and I am a member of Group 4. I'm here today to talk to you a little bit about the individual analysis of my LEWAS Lab Day, September 26th, 2016, as well as the parameter turbidity. September 26th, 2016 was a wet day. Of the 3 days that we selected to analyze, September 25th, 26th, and 27th, the 26th had the highest accumulated rainfall, a total of 1.25 inches. The rain began around 1:30 p.m. and continued throughout the rest of the day. Prior to 1:30 p.m., the conditions were dry. The rain began heavy and tapered off to light rain, which continued. These details are courtesy of the website www.weatherunderground.com. The parameters that were most affected by the rain event were specific conductivity, turbidity, downstream velocity, and water depth. As you can see in this graphic representation, specific conductivity dropped sharply as the rainfall event began. Turbidity also increased sharply at the onset of the rainfall event. As the rain fell, the downstream velocity increased, as one may expect. Image courtesy of memegenerator.net. The water depth also increased sharply with the rainfall. The parameters pH as well as redox potential also seemed moderately affected by the rainfall event. Here you can see the pH value reacting to the rainfall. This graph shows the redox potential falling and then gradually recovering as the rainfall tapers off. It was fairly easy to see correlations between rainfall and larger scale macroscopic properties such as water velocity, depth, and turbidity. Rainwater loosened sediments and increased the water volume entering the stream, which obviously affected these parameters. Chemical, electrical, and microscopic factors were more difficult to directly correlate. Even values that seemed related to each other, such as pH and dissolved oxygen, failed to produce useful R-squared values, even though the individual graphs tracked together visually in a convincing way. Excuse me. What is turbidity? Turbidity is the measure of relative clarity in a liquid. It's an optical characteristic of water and is an expression of the amount of light that's scattered by material in the water when a light is shined through the water sample. The higher the intensity of scattered light, the higher the turbidity. Material that causes water to be turbid include clay, silt, finely divided inorganic and organic matter, algae, soluble colored organic compounds, plankton, and other microscopic organisms. On the dry day, the turbidity sensor was likely blocked by some piece of crud or debris. Later in the day, it became unblocked and turbidity dropped to 0. A reading in the thousands is not only unrealistic, it's unadvisable. 0 would be the normal dry condition reading. The wet day turbidity graph shows a reading of 0 during the dry part of the day, and then the reading skyrockets up to almost 400 as the rainfall event occurs, gradually tapering back off to normal conditions. The semi-wet day turbidity graph shows mostly 0 readings for normal conditions, and a sharp spike as the rainfall begins and ends. In conclusion, stream turbidity can be convincingly correlated to rainfall. On both wet and semi-wet days, the turbidity readings show significant spikes during the periods of rain. Rainfall brings runoff into the stream and increases the stream depth and velocity, which increases the amount of sediment suspended in the water body, thereby increasing turbidity.